No, we're going to talk next about using snapshots um, and adding and editing virtual hard disks. Snapshots are a really good way to implement something, a principle we use in virtualization called non-persistence. Um, and it can actually go all the way up to having non-persistent hard disks, which is to say, a VM which discards its state at the end of every session and always comes back running the way the VHD is. It's like the virtual hard drive file is read-only, and you can make changes during the session, but at the end of the day, it all goes back to the way it was. Snapshots are a way to capture a moment in time. The VM's configuration, its connections, its data, all of it. This is a very good solution. This is a very good idea for whenever you make major changes to a VM. Say, for example, you're spinning up a server VM and you're going to have it do several things. And so you spin up the first service, you configure it, you test it, you make sure it's working. Before you move on to the next one, take a snapshot so that if something goes sideways with the next service you add and configure, you don't have to throw it all away. You can start from that new baseline. It's not exactly a baseline, but it's almost like it's like a save point in a computer game. You don't have to go all the way back to the beginning of the level and fight your way through all the zombies or whatnot. You can start at the last place you were safe before things went sideways on you. Um, it is a very good idea if you're installing new patches, if you're doing particularly if you're doing an OS update. Say, particularly if you're doing an OS update, and you have any reason to believe that there's a chance that that OS update will make things worse, which does happen. Uh, Microsoft's Patch Tuesdays are notorious in the industry for this. Occasionally, other vendors' patches will cause as many problems as they solve. Um, the bottom line here is that writing quality software is difficult. And the more complex that software is, the more moving parts it has, the harder it is to patch one thing without breaking something else, unless you do a fairly exhaustive, comprehensive regression test, which is to say you run all the old tests from all the old development process to make sure everything, literally everything, still works. And if a regression test fails, you figure out why. What new thing did I fix? What thing did I fix broke something that was working before? Or what new feature did I just add that broke something that used to work? This is what regression test is supposed to find. Uh, but not everybody regression tests, and not everyone who does it as comprehensively as they should. Now, there is a sane limit to how many snapshots you have. The hard limit is available disk space. The sane limit is not to keep snapshots for weeks on end. That's just going to accumulate cruft on your hard drive. So it would be a good idea to take maybe the first snapshot right after you built everything, then snapshot again when you get in your initial configuration right. And then if you want to snapshot things along the way, fine. But as you make a new snapshot, throw some of the older ones away, with the exception of your initial and your initial good configuration, because you really don't want to accumulate a whole bunch of snapshots. One thing you can do, if your hypervisor allows you to decide whether or not to snapshot at any given point in time, say for example every time you shut down, tell it to ask you. Don't just have it capture a snapshot, because particularly if you're using, say, you were talking about a desktop virtualization, and you spin up a VM just to use it for an hour or two to do whatnot, but you haven't made any changes that you need to retain. Um, and you certainly don't need to make sure that that save point is persistent, you can just shut it down, let it save, and if there are no real changes to make, don't save anything. Let's also talk just briefly about adding and editing virtual disks. This is actually our snapshot screen. You can actually see it as a kind of a timeline, a tree of related snapshots. So if you've got, say, you've got your main one and this one maybe seems to be saving itself on a regular basis. If you have a chain of these, delete some of the early ones. And in terms of adding and editing virtual disks, you could have as many as 30 on each. If you use the Create Virtual Disk Wizard, you can either um, choose an existing hard disk image and do that, or you can create a new one. The Virtual Media Manager also manages your virtual hard disks, floppy disk images, optical ISO images, and all of that, whether they've been used currently or previously. You can actually move, copy, or modify these VHDs. And you can also put them in various states. Normal, write through, shareable, immutable, and multi-attach. Multi-attach means that that VHD is attached to multiple virtual machines. Normal is your normal running state. Write through might actually treat that virtual hard drive as though it were a physical drive and write through to something, a physical disk. Immutable, I believe, is analogous to your non-persistent disk. Its state is saved. You can't change it. And this is what that interface looks like. So you got your hard disks, your optical disks, your floppies. You'll see their sizes. No, their virtual size and their actual size. The difference between this virtual and actual size tells me that this is a dynamically allocated storage. Even if you didn't see this window down here, if you can see it, if there's a numerical difference between your virtual size and your actual size, this is what we would call a dynamically allocated storage virtual hard drive, or thin provision disk. You can actually see its UUID, you can see what it's attached to, you can see its location, its format, and whether or not it's encrypted. If you copy a VM from one place to another, literally everything will come over, including the UUID. If you want that copy of the VM to be functionally separate from the main one, one thing you're going to have to do is let it invent a new UUID. The UUID is the universally unique identifier. It is a relatively newer way of identifying partitions, really. If you remember from the Linux course, if you've taken it, and we discussed storage and partition and things like that, newer versions of etc tab actually use your UUID in place of the /dev device identification address. So the UUID stays with the partition, even if you rearrange your hard drive. Say instead of you swap SATA 0 and say you have 3 virtual SATA drives, and for whatever reason you swap SATA 0 and SATA 3. Sorry, SATA 0 and SATA 2. If suddenly dev SDA A is now dev SDA C, and your FS tab is in the old format, that's a problem. But with UUID, it's going to find it wherever it is, no matter what SATA controller it's on. So those UUIDs are an important part of how modern systems, modern OSs handle your drive partitions. And fundamentally, that file, that virtual hard drive, is a file that's pretending that it is a hard drive partition. Okay, so in the next video, we're going to talk about creating clones. Thanks, and I'll be right back.